So working with solving polynomial equations, if we take a couple of examples from today's classwork. For number 10, we have x cubed plus 64 equals 0. Hopefully at this point in time you recognize this as the sum of cubes because we do have x to the third plus 4 to the third equals 0. Again, hopefully right now you can say 64 is 4 cubed. And that is going to be equal to, hopefully you remember, we just talked about it. We have a plus b times a squared plus ab plus b squared. So we can do some filling in, some substitution. And a is going to be equal to x, and b is going to be equal to 4. And now we can just go ahead and substitute those values in here. Okay, so I've gone ahead and done that substitution. And we have x plus 4 times x squared plus 4x plus 16 equals 0. We know that we can go ahead and do the zero product property. Goodness. And then we have x equals negative 4. That's one of our solutions. X equals negative 4. And then we have a quadratic. In this quadratic, if we were to look at it and we just did the discriminant. So if you recall, the discriminant is b squared minus 4ac. If we went ahead and figured that one out, we have 4 squared minus 4 times 1 times 16. So this is going to be a negative discriminant, which means we have two imaginary solutions. And so if we have imaginary solutions, my discriminant is less than 0. That means we are going to need to use the quadratic formula. And there is your quadratic formula. And remembering that in this little guy right here, a equals 1, b equals 4, c equals 16. So we're going to have x is equal to. All right, so as we continue to work with the quadratic formula, I've simplified down to negative 4 plus or minus the square root of negative 48 over 2. We should be able to go ahead and divide up our common denominator and simplify the square root of 48 all at the same time. So I know that the square root of 48 is going to be the square root of negative 1 times 16 times 3 over 2. And again, go ahead and simplify. This is going to be negative 2 plus or minus. We know that negative 1 is going to become I. We know that 16 is going to become 4. So if we rewrite that accordingly, we have 4i with the square root of 3 remaining, all of that over 2. These two things are going to simplify down. So I am going to have negative 2 plus or minus 2i square root of 3. There you have it. That's your x equals. So looking back, we have 3 possible solutions. We have x is negative 4, and then we have x is equal to. All right, if I go back here and I make some corrections, this should have been a negative all along, right here. And this should have been a negative all along. Let's see, so what would that have done along the way? That would have changed this to a negative 4, would have changed this to a positive 4, positive 4, positive 4, positive 2, positive 2. There we go. So we have x equals negative 4 and x equals 2 plus or minus 2i square root of 3. 3 possible answers. All right, so looking at number 36, we're going to look at finding the real solutions by graphing. And in order to get it graphed, I do need to get it into standard form. And if I just rewrite that real quick, because, well, if it's not in standard form, I can't exactly put it into the graphing calculator. And in doing this, I could, let's see, I'm just going to do it all by hand for now, just to show that it's capable. Since I have 4 terms, I am probably looking at factoring by grouping. And in doing that, let's go ahead and do that real quick. So factoring by grouping, I end up factoring out my greatest common factor, which is 3x squared, and then leaving behind x plus 4. And of course, if I factored correctly, my inside is going to be the same. And then negative 12 divided by 4 is going to give me negative 3. So I'm able to go ahead and reorder these, and I have 3x squared minus 3 equals 0, and x plus 4 equals 0. So we know that one of my solutions is x is negative 4. The other solution is going to be a little bit different. Go ahead and divide by 3. We have x squared equals 1. Find the square root of both sides. We know that x is going to be equal to plus or minus 1. So I have x is equal to negative 4, x is equal to 1, or x is equal to negative 1. And if I go ahead and take a picture here of what the calculator is going to look like. Okay, and now that I've proven it or done it algebraically, if I go ahead and plug it into y equals, and I've gone ahead and plugged the entire polynomial in, and looking at the graph, you can see that it appears to be that my roots do actually occur at, here is origin, negative 1, negative 2, negative 3, negative 4. So yes, that is x equals negative 4, x equals negative 1, and again, x is equal to 1. So you can see graphing wise that my roots are crossing over the x-intercepts there. All right, for the last example here, we're talking about modeling a situation, and close friends Stacy, Una, and Amir were all born on July 4th. Stacy is 1 year younger than Una. Una is 2 years younger than Amir, and on the 4th of July 2010, the product of their ages was 2,300 more than the sum of their ages. So how old is each friend on that day? And they've given you some requirements here. Let x equals Una's age. We don't know how old she is, but we do know that Stacy was 1 year younger, so that would be Una minus 1. And Amir's age, Amir was 2 years older than Amir, or Una was 2 years, Amir was 2 years older, or Una was 2 years younger, depending on how you look at it. So using x as Una's age, Amir would be x plus 2. So write an equation to simplify and change it to p of x, not a big deal. So the sum of their ages was Una, Stacy, and Amir, plus 2,300 is going to be equal to the product of their ages, which is x minus 1, x plus 2. Simplifying this down, we've gone and combined like terms, and we have done some multiplication over on the right-hand side. And again, haven't done anything with the left again. We have multiplied on the right-hand side. We've combined everything now, and we have a polynomial equation. X cubed plus 2x plus 5x minus 2,301 equals 0. And we can go ahead and plug that into the calculator and find some solutions. And you can say only one real solution, graphing it, use the 0 feature. So we were looking for when y equals 0, what is my x value? So that is a realistic 13. And then what are 3 consecutive integers whose product is, let's do this next example, and it says what are 3 consecutive integers whose product is 480 more than their sum? Okay, so using that as a sort of a basis of what we're going to do, let's go ahead and use this example again. What are the three consecutive integers whose product is 480 more than their sum? So we know that the product, well, let's figure out what these integers are. Three integers. We don't know one, so we have an x plus 1, and x plus 2. So we know that we have x plus 1 plus x plus 2. This is our sum, and we know that our sum, what are the consecutive integers whose product is 400 more than the sum? Well, shoot, if it's more than the sum, that means we would have 480 plus that is going to equal the product. So what I'm going to do now is I'm going to do some combining like terms. All right, doing some inverse operations, doing some multiplication. I went ahead and FOILed out the entire right-hand side to where I got x cubed plus 3x squared plus 2x. And I've gone and done the inverse operations to get everything over to the other side. And in doing so, if I rewrite it, I have a negative x cubed minus 3x squared plus 3x, plus 3x plus 2x is going to give me plus x. All right, so we get plus 483 is going to be equal to 0. And in doing so, we're going to go ahead and we can put that into the calculator. And we should end up getting the same solution. So if you can see, let's see, I'll zoom in with my picture. As you can see, I've gone and put this in standard form. I've placed it in the graph, and we see that it seems to be crossing over 1, 2, 3, 4, 5, 6, 7. X equals 7. Now, if that is going to be my solution, I should turn around and say, well, if x is 7, then I know that the x is 7, x plus 1 is 8, x plus 2 is 9. So there's those three consecutive integers with the product of 480 more than the sum.